Hi, Algebra 1. Here we are in section 1.6, and today we will discuss the commutative and the associative properties. So we're going to treat our vocabulary today as the words commutative and associative property. And when I think of the word commutative, right, I see the word commute in there, right? And we know that commute means to travel, to go from one place to another. So I think about that when I think about this property. So I think about traveling when we deal with the commutative property, about moving things around. And so if we look at this image here, it says for any, or for this key concept rather, it says for any number a and b, a plus b is equal to b plus a, and a times b is equal to b times a, which shows me addition and multiplication. So we can have a commutative property of addition and a commutative property of multiplication. And the examples are here. 5 plus 6 is the same as 6 plus 5. That's addition. And 3 times 2 is the same as 2 times 3. So in brief, we would write this, and just as we had in symbols here, as a plus b is equal to b plus a, and a times b is equal to b times a. And my point in talking about traveling is as if the a traveled to be second on the other side of the equal sign and b traveled to be first. So it doesn't matter what order they travel in, how they commute, if they move around, as long as you are adding or multiplying the same two values, you're going to get the same answer. So that's the commutative property of addition and multiplication. Just a quick note, I want you to think about this. Don't answer it yet, because I'm sure you'll probably have to answer it in your assignment. Does the commutative property work for subtraction and division? If not, tell me why. All right, we can talk about that when we see each other. The next property or vocabulary word we're going to talk about, and this key concept, is going to be the associative property. And when I think about associative property, I think about who I associate with, who I hang out with, right? So, in this particular case, we're looking at the associative property of addition, and over here, we're looking at the associative property of multiplication. Let's get a little bit deep into it. So if I'm adding three numbers, a plus b plus c, if I choose to, remember parentheses gives importance or priority to a certain operation. If I add a plus b first, then add c, it's the same thing as adding a plus the quantity of b plus c, right? So adding b plus c first and adding a. This is going to yield the same concept, the same answer. So these are equivalent. Similarly, I can say the same thing when I'm multiplying a times b first, then multiply c, or do b times c, then multiplies a, then multiply a. I have the same thing. So those are that's the symbolic representation of our associative property of addition and our associative property of multiplication. And so after feeling comfortable with the, symbolic representation, you can just take a look at these examples and confirm to yourself that, yeah, it makes sense that this is true. And of course, the reason why I call it associative, in my mind, I think of numbers as my friends. Yes, I do, people. And I think, okay, it's okay if these guys are hanging out a little bit closer and then I get to come along. Let's say I'm C and I get to come along later. It's the same thing as me and somebody else hanging out and our other friend comes. We're still equivalent. We're still friends. We still have this relationship. I don't know, maybe it's taking it too far, but that's how I think of it. So I think about associative property as bringing the parentheses in and associating two things that were not necessarily associated first together, but still everything is being added or multiplied. My question to you again is, similar to the last concept, would the associative property be true with subtraction and or division? Show it to me, prove it to me, talk to me, tell me. I think you'll have an example, as I said before, in your assignment around this line, around this concept. So here in example 1, we're going to think about the properties as we evaluate a pretty simple problem. We're multiplying 8 times 2 times 3 times 5. And if you had this problem, you could literally just go 8 times 2, 16, 16 times 3. And I know some of you would just pull out a calculator. I hope you see my face in your mind frowning. Not happy with that. We don't need a calculator. And so here's one use of properties that gives us an opportunity to do problems where we can feel more confident not actually using a calculator. One thing that I notice here is that it's totally easy for me to multiply 2 times 5 and get 10. And when I have 10, it's easy for me to multiply anything times 10. So what I can do is rearrange this. What is the property that allows me the opportunity to rearrange? Do you remember where I'm moving things like they are commuting? Very good. The commutative property. So this gave us the power to move things around, which is cool. And now I talked about wanting to multiply 2 times 5. So if I want to multiply 2 times 5 and I want to focus on doing that and not going 8 times 3 times 2 times 5, I really want to get that 10. I'm going to put parentheses around here and say that this is the same as multiplying. Like this answer would be the same as this answer would be the same as this answer. What gives me the opportunity or the right to put parentheses around it to make these guys associate together? Yeah, of course, the associative property, right? And so what I do now is 8 times 3. I do know that because I did memorize my timetables. And then 2 times 5 is 10. And I know that multiplying by 10 really just means putting a 0 at the end of the number, moving everything over. And so now instead of having 24, I have 240. Wasn't that simple? I know that you're not going to say in your mind, hey, wait a minute, can I apply the commutative property here? Wait a minute, can I apply the associative property? I get it. I get you would do this automatically if you're not using a calculator. I get you would do it automatically, and I'm glad. But what I want you to keep in mind is that in math, we need to have reasons why we do things. Why is it okay to do this? And these properties are just emphasizing the legitimacy of the thing that we would do naturally. Here's an example where we are taking a look at a subway map or a train map in, where is this from? I think this is in Atlanta. So we're going to use the addition property. And so we're referring to some stuff in the beginning of the chapter, and I have a copy of the picture right here. So we're going to find the distance between 5 Points and Lakewood, Fort McPherson. And that's this path highlighted here. And so what we need to do to find that distance, everybody would do this, I know you guys know, is you would basically say, okay, they've given us the distance between each place. We would simply add it up. So let's do that. So I've listed my distances here, and what I'm noticing is that, I don't know about you, I'm not pulling out a calculator, but there are some numbers that fit together a little bit better than others. 1.5 and 1.5 fits nicely together because it's going to give me a whole number. So I'm feeling like I want to do that, and what happens is I can rearrange these numbers due to the associative property of addition to look like this. And then what I'll do is I will put parentheses around here, and what do we know this is? I'm sorry, I said associative. I can move it by commutative, right? Because commute means to move. If I said that, I forgot. Anyway, I can move it by commutative property. I can move everything around. And the associative property is where I put my parentheses, right? So I'm going to simply join them together. These guys come together to give me 3 miles, because 1.5 plus 1.5 is 3. These guys come together to give me 1.1 plus 0.4. I'm going to add the numbers in the tenths place together. So 0.1 and 0.4 give me 0.5, 1.5 miles, right? And then altogether, I have 4.5 miles. So to travel from 5 Points to Lakewood, Fort McPherson is 4.5 miles. Yeah, we did it. Let's look at another one. So in this problem example 3, we're going to be doing some simplification. And what I want you to see is that we have a number outside the parentheses. We've got this variable here. There's nothing to do in the parentheses. I'm hoping you're recalling last lesson where we had to use the distributive property. And so we're going to do that. First thing I like to do is say, let's handle distributive property, get rid of all the parentheses. So I have 3c plus 5 times 2 is 10. And 5 times c is 5c. And remember, when we simplify, we are going to compact our problem, compress it in a sense, join like terms together. So the next thing I need to do is observe what are like terms, and that would be 3c and 5c. So I'm going to join those bad boys together to get 8c plus 10. And I cannot get 18c. I will not get 18c because this is 8 c's and 10. Think of it this way. We can't join these guys together because they don't look alike. Or this is like my this is like having money for 8 cups of coffee and then having an extra $10. I don't know what this is, how much each cup of coffee costs, so I can't say 8 plus 10 and call them the same thing. I don't know, I might have overspoke that, but I hope you just know you can't join them together. We're done. Let's do another one. So here in example 4, we're kind of going back to what we talked about in a lot earlier where we're translating verbal expressions into algebraic ones. So here in part A, we're going to write an algebraic expression for the verbal expression up here. Let's look at the verbal expression. It says use the expression 4 times the sum of A and B increased by twice the sum of A plus 2b. Let's figure out what this looks like. So we're multiplying 4 times a sum of something. So we can start off with 4 times a sum. So that's going to be some stuff. right? So 4 times whatever is in here has to be the sum of A and B. So 4 times the sum of A and B. Like that. Sum means add. And the next thing is now that thing, 4 times the sum of A and B, 4 times the sum of A and B is increased by twice the sum of A plus 2B. So it's increased. Increase means to add. It's increased by twice something. Twice what? Twice the sum of two other values, A plus 2B. You might want to read that over and just kind of sit with it for a second before you, agree that what I have here makes sense, all right? So the next thing that we're going to do is simplify, right? So it says to simplify the expression and indicate the properties used. I'm going to be honest with you. If you think of the property and it comes out and pops out at you, you can write the property down. If you don't, that's okay, but you need to be doing it in a correct manner. So let's take a look at how we'll do this. The first thing I would ask you to do, I'm going to just rewrite this problem down really quickly. The first thing I would ask you to do is to get rid of the parentheses. And to get rid of the parentheses, in a sense, I like to say free them from the parentheses. You can't actually do what's in there first because those are unlike terms. We're going to use the distributive property. Multiply through by the number on the outside of the parentheses. So then I get 4A plus 4B plus 2A plus, now 2 times 2B is 2 times 2 is 4, 4B. So this is what I get when I use the distributive property, which gets rid of the parentheses. So the next thing I'm going to do is simply join like terms together. So in a way, I'm going to use the commutative property. So commute, remember, we can move things around. So 4A plus 2A, because those guys go together, plus 4B, that's this guy, plus this other 4B, that's this one right here. So this will be the commutative property. And so here your text would ask us to put parentheses around this and say I'm using the associative property. Yeah, I'm going to join 4A plus 2A, and I'm going to get 6A, and 4B plus 4B, and I'm going to get 4B's and another 4B's. I'm going to get 8B, and that's cool. There's a couple ways to break this down further and say, well, we're using the distributive property again, saying that we're going to add the 4 and 2, recognizing that the A is coming along for the ride. I'm not really asking you to split hairs on that level. I feel like it's a little bit too much. So what I've done here is enough in terms of writing down your properties. Is that all right? I hope it makes sense. Call me, let me know, text me, tell me something's not working out if this doesn't make sense. And I look forward to talking to you soon. Take care and work on your assignment. Be blessed. Bye-bye.